So in this lab we are going to create the layout of Common Drain Amplifier. So I have clicked open our library and I have clicked on the file that has the schematic and the symbol. So I'll click open the schematic. So this is our schematic, right? Always remember that you need to create the layout from the schematic file. Okay, so now schematic file is open. Now from here I'll click on launch and click on layout Excel. I need to create a new one, so I can see that create new is already clicked on, so I'll just click on OK. This layout will be created inside of CD amp file, which is inside my library file. So I'll just simply click on OK. So this is our layout schematic window. Okay, so maximize this. Connectivity, generate all from source. Just click on OK. I've got it. Now first things first, I'll delete the PR boundary. Done. Now Shift F. So I got the inner structures as well. Now I'll just move back to my schematic and I want to see that in my schematic both are nMOS, isn't it? Common drain means both the MOSFETs are nMOS. Okay, now because both are nMOS, can you see the body terminals are connected together and grounded? Okay, now the bottom MOSFET has a width of 1.8 micro and the top MOSFET has the width of 9 micro. That is why the bigger width nMOS looks like this. So I understand this is the top MOSFET and the shorter width nMOS is this one, just looking at the size, and that will act as the bottom MOSFET. So now I know that this one will move on the top and this one will go down. Another thing that I know and I have to pay attention to, that the body terminals have to be connected to each other and then grounded together. So that is another point to be noted. Okay, now I want to know what are all these pins. So I want to see what is this pin. Okay, so this is V bias. Let me check out this one. This is V in, ground, output, and VDD. Fine. Now you might say or think that these pins are exactly where they should be, so what is the need to check them individually? Because sometimes in Cadence it happens that they are misplaced and you might get confused. So it's always better to check them out, right? So I want to bring this down, so I click on it once and drag it to the bottom, and it goes either horizontally or vertically, not together. So I just brought it down, then I'll slide it over here, bring it somewhere over here, and then drag it so that I have ample space for ground terminal also, right? Now I do not have much space to maneuver this one, so I'll just click on it and drag it to the bottom, to the top. Okay, right? Now connectivity, nets, show or hide all incomplete nets. So now, like, Cadence is directing that you need to connect this to that. Okay, so now first of all, since body terminals are not present automatically, so first things first, I will get the body terminal. So this is the top MOSFET. just look at the schematic, how the connection is. The body terminal is separately connected to the body of another MOSFET. So that means the body terminal of this top MOSFET cannot be in integrated mode. Okay, so what is the other mode? Detached. So select the MOSFET, press Q, then go to parameter, body die type, none, I need it to be detached. So I've clicked on detached. Okay, now this is the bottom MOSFET. Go back to the schematic, see that the body of this terminal is connected to its own ground, because ground is connected to this MOSFET, right? So you can make it integrated. Okay, you can make it integrated and you get connected separately. Okay, so click on it, press Q, body die type is integrated, because source and body are connected in this one. Okay, now if I start connecting from here to here, there will be a lot of difficulty to connect the body terminals together. Okay, and since I have to make this detached, since I have made this body terminal as detached, so on which side it is on? It is on this side. So that means this part, this one, okay, this light blue color outline, that is going to be a source. Okay, and this side is the drain. Okay, this side is the drain, this is the source, right? Now this source has to be connected to VDD, so it will get a little bit messy. So what I will do is, I will just rotate this. I will just rotate this MOSFET so I can make the placement proper. Select the MOSFET, and over here can you see this rotate option, semicircle with an arrowhead? Okay, or from there you can go to this arrow, you will get extra options over here. So this is flip vertical, flip horizontal. So if you flip it horizontal, it will move on this side. I don't want that. If I flip it vertical, it has become upside down. So I don't need all those things. Okay, so we will just rotate this, and I'll just rotate this. Click on that option. Okay, I have clicked on that option, that's why I'm getting that rotating symbol around the cursor, and click on the MOSFET that you want to rotate. So I have rotated this, so this looks now in this fashion. I'll zoom it over there. So this detached one I know is the body terminal. This is on this side, so this becomes my source. Another thing from how you should know, wait, so if I move this, so this is the source. Okay guys, this, if I move this pin like this, okay, can you see the orange line is ending on the top bar only? So that means this is my source, because source should be connected to VDD. And if I move this output pin, so this ends over here in this second bar, so that is my drain. Okay, that is my drain. And of course if I move this, this is in the middle, connected to the gate terminal. Okay, now if I am rotating that, I should rotate this also, so that I can connect the gate terminals properly, input, because if I try and connect them like this, it won't happen. So yes, so input from the left side connected to the middle terminals, and source and drain on both the sides. Okay, so now I'll just move it a bit closer. I'll move this output pin a bit onto this side, and I'll move the input pin slightly over here so it's a straight line. Yeah, and I'll bring this ground pin somewhere over here. Yeah, done. Right, so now let me bring this a bit. Okay, so now let us start connecting. So first things first, let us connect the input first, right? So this is a metal in blue color, metal 1, if you remember from our previous session. This is the light green color depicts polysilicon, so that forms our gate terminal. So I'll bring my cursor over here, press P. P here is for path. Single click on this side, bring it down, right click, wire down to poly, place it, single click and place, and then connect. Okay, so yeah, press P, again wire down to poly, single click, connect. Okay, so inputs are connected. Now if I look at the bottom nMOS, source and drain are interconnected, right? They are integrated. Okay, I'll take use of the downward arrow key. This is also metal 1, this is also metal 1. Path is already selected, so I don't need to press P. Single click and connect. So ground is connected to the bottom nMOS. Now the top nMOS's body terminal should also be connected to it. So I have to do some thing over here. Okay, that I will do later on. Okay, that needs some maneuvers, but and that can only be done with the moment I finish the output connection as well. So output connection means drain to drain. So I will zoom it over here. Okay, press P. This is my drain. Okay, single click, that will create a diversion, and then press the downward key. Okay, single click. Okay. You can drag it down also, as I am doing it over here. Okay, then I have to connect this to the output line. Okay, this is done. clear. So now this body terminal has to be connected. Okay, now this end is covered, that end is covered, where to bring it down and how to bring it down. So what I will do is I will just select this. Okay, wait. I'll just delete this connection. Okay, and I'll bring this input pin a bit closer so that I have some space for this wire to be connected over here. Okay, so first let me finish this one over and then we'll move on to the input connection also. Bring it down. So the body terminal of the top MOSFET is connected to the body terminal of the second bottom MOSFET, and that is connected to the ground. Output terminals are connected. The only thing left is the input connection over here and the VDD connection at the top. So let me complete this input connection. So that is also connected. Now I have to connect the VDD and source. So this is my VDD. Okay, I'll take this and I'll connect it over here. So this is the layout of Common Drain Amplifier. So from here, what did we learn? Difference is that in this, since both the MOSFETs are nMOS, so the body terminal connection of the top MOSFET is changed, and the change in top should match, change in the schematic should match the layout, and this by now you have known. So I will save this. Okay, so now after I've saved it, we'll go to Assura. Okay, so technology is already set up. Now I'll do run DRC. Okay, GPDK 180 is written. I'll just click on OK. Okay, so there is one issue. Let us see what. So this is the mismatch, right? Okay, so we can shift it. So I have rectified that issue and I'm running for DRC again. So now there are no DRC errors. So if you are getting an error, check where the error is and rectify it. So that is taken care of. So we had just one DRC error. Okay, then after DRC, time for LVS. So we run the LVS, everything is done, and then I'll just click on OK. Want to see the watch log file. We will. So no mismatches are there from the schematic, and this is what we want. Schematic and layout match. Okay, you can close this. After DRC and LVS, it's time for QRC. It's time for QRC. So okay, extraction tab, ground exclamation mark. I need both RC, so that's also done. I'll just click on OK. QRC will run. So QRC has given us its results, so I'll just check it on. So over here I've got the AV extracted. Looks like the layout, but it isn't the layout. So I'll just, now everything will be names, so I'll just press Shift F. So I can see a component over here. It's a Parasitic resistor. Value is 350 milli ohms. Okay, let us check something else. Again a resistor. I need a capacitor. Resistor. I got a capacitor over here, and the value is 106.482 attofarads. Attofarads is 10 raised to the power of minus 18. Okay, so this completes the layout of common drain. In our next session, we'll look into the layout of common source. So this is all for today. Thank you. If you have any doubts, you can contact me, and you know how. Thank you very much. I think we will wrap it up today. Thank you.